Right, here we are for the solutions / hints to review 2. Make sure that you've tried this first on your own and given it a good effort on your own without the use of your notes, then use your notes, and then last come to this video here. Remember, if you view this as a real test and take it seriously, then you're going to get a lot more out of it. Alright, so expand using the binomial theorem. What I'm going to do is actually just write that out and maybe say a few things about it, and then talk a little bit more about this question right here. Alright, so here's the expansion for 3 minus x to the 5th. My a value is 3, my b value is negative x, and so that's why there's that negative x here. And then I just followed the binomial expansion. A good refresher might be to go back and watch 2.22 and 2.23 to help you understand why this is the case here. But just to give you a basic idea, imagine that you had 3 minus x multiplied by itself 5 times, and think about all the different ways that I could multiply that out. Remember, when we're multiplying binomials, you have to take something from each binomial and multiply it by something from every other one. So the first thing you can do is take 3 from each of the binomials and multiply them all by themselves, and that would give you 3 to the 5th. Of course, there's only one way you can do that. Remember that you're choosing none, or 0, choosing 0 of the negative x's, so it would be 5 choose 0, 3 to the 5th. The next thing I could do is I could choose 1 of the negative x's and 4 of the 3's. And so the number of ways that I can do that is, well, I have 5 of these binomials, and I want to choose 4 3's and only 1 of the negative x's. So 5 choose 1 would be the number of ways that I can get this combination. I can use either Pascal's triangle or the closed form way of figuring this out. So n choose k can be computed using n factorial over k factorial times n minus k factorial. So this is really just a number, right? The number of ways I can choose one thing out of a set of 5, and that happens to be 5, and then I compute 3 to the 4th as well, and that actually happens to be 81. And so 5 times 81 will be 405. Negative x to the first power is negative x, so it's negative 405x, because there's that negative out front. And then continue going on and on. Here for the second one, however, what is the coefficient of the x to the 8th term? So if I were to expand this out, when I get an x to the 8th term, what's the coefficient going to be? And so if I just start this off, right, 8 choose 0, x squared to the 8th. Well, x squared to the 8th is x squared times itself 8 times, which is x to the 16th. So that's not going to be x to the 8th. So I've got to think about what will get me x to the 8th. So thinking about this, and I remember I'm dealing with an x squared, so it would be x squared to the 4th power. So that's the term I'm looking for. So here I have the 8th, the next one would be the 7th, and so I could think about continuing onward, and finally I'm going to get to the 4th. So it's going to be 8 choose 4, x squared to the 4th, and then I also have negative 1 to the 4th. And the way that I know this is going to be to the 4th is, remember, so this would be x squared to the 8th, and here there's also, and I should have written it in probably, a negative 1 to the 0th. Here there is a negative 1 to the 1st, right? And so I remember that the coefficients, the exponents of my a and b values will need to add up to n, which is in this case 8. Okay, so when I get to the 4th here, I know I'm going to have negative 1 to the 4th. 8 choose 4, what I would do is I would calculate 8 choose 4, and I would calculate negative 1 to the 4th, and I know that x squared to the 4th is going to be x to the 8th, which is exactly what I was looking for. So negative 1 to the 4th is negative 1 times negative 1 times negative 1, which is positive 1. And then giving us a little more space here, I can actually compute 8 choose 4. I'll do that down here. 8 choose 4. And this is going to be 8 factorial divided by 4 factorial times 8 minus 4 factorial, which is just another 4 factorial. And so when I write this out here, I'm going to have 8 times 7 times 6 times 5 all the way times 1, dividing it by 4 times 3 times 2 times 1 times 4 times 3 all the way to 1. And so what I see here is that I have some common factors in my numerator and denominator, and so this 4 times 3 times 2 times 1 is the same as the 4 times 3 times 2 times 1 up top. And then I can also do some more. So notice here that 8 divided by 4 is the same as 2, and 6 divided by 3 is also the same as 2. And at this point, I am done simplifying. And so I have 2 times 7 times 2 times 5. And so maybe the quickest way to do this is do 2 times 5, which is 10. 10 times 7, which is 70. 2 times 70, which is 140. And in my denominator, I have 2, which is just giving me 70. Right? And then what I could have seen is that I could have then gone through and said, hey, 2 over 2 is also 1, and so that's where I cancel that other 2. So this is going to be 70. So here this is 70, this is 1, so I have 70 times 1, which is just 70, and so the coefficient of the x to the 8th term is 70. All right, here we go with Brian, Isaiah, and Raul. What I'm going to do is just kind of write everything out, put it up there, and then talk just very briefly about it. Right, here it is. This one has 3 people involved in it, but the relationship remains the same. The work that Brian does, plus the work Isaiah does, plus the work Raul does, will equal the total amount of work that they do together, which is 2 rooms painted. I know that the work each person does is their rate times the time they work. They work for 3.5 hours. The rate Brian works is 1/6 of a room per hour, since he can do 1 room in 6 total hours. Isaiah works twice as fast as Raul, so that means he will get twice as much done per hour. So instead of doing 1/6, he gets 2 times 1/6, which is 1/3 of a room per hour. And what we're looking for is how long it will take Raul to paint 1 room. And so we know if we solve for the rate at which Raul works, R sub R, that we will be able to determine how long it will take him to paint 1 room. So we go through and we set up our equation and solve for R sub R, which is 1/14 of a room per hour. And you might be able to say right from there, okay, 1/14 of a room per hour, that means for 1 room he'll need to paint for 14 hours. Or you can remember that work is rate times time. So the amount of time it takes you to do amount of work is the work divided by the rate. So the time it takes him is 1 room divided by 1/14 multiplied by the reciprocal here. So it would be 1 times 14 over 1, and that gives you 14 hours. With the mixture problem, I'm going to go ahead and write out the solution and maybe talk briefly about it, and then move on. Right, so here we go. I've worked through it, and there's quite a bit, but you should have gotten most of this on your own. 200 milliliters of a mixture, 25% of it is acid, so that means 50 milliliters is acid. I'm looking at the concentration, and the concentration is the pure amount divided by the total amount. And so now I can start to think about what makes up the pure amount and what makes up the total. I start with 50 pure, and then I'm going to add some amount to it. And I start with 200 total, and I'm going to be adding some amount, right? The same amount on the top and the bottom. And I want to solve for where the concentration is 33%, or 0.33. So I set up my equation and solve. I showed the first step here where I multiply by 200 plus x to get my variable out of the denominator. Gets me to this point, and then I can just solve for x, which will give me 23.88 milliliters. For the second one, I want to decrease the concentration, and I can't subtract away acid once it's been mixed in, right? So I can't say 50 minus x. That's not going to work. So my only option here is to add water, or add something that will not increase the pure amount. So I can think about this equation here where I have 50 divided by 200 plus W, where W is some amount of water that I'm adding. And now when I add W, I'm going to be decreasing the concentration. I'm going to be making this fraction smaller by making the denominator bigger. So you can go ahead and set it equal to 0.11 and solve, and you'll get that you need to add 254.5 milliliters of water in order to decrease your concentration to 11%. So here, you're going to go through and perform the following operations. I'm just going to say a couple of things. If you're subtracting, then you need to make sure you get a common denominator, same with adding. And remember that when you divide by something, you're really just multiplying by its reciprocal, right? If I have 4 divided by 5, that's the same as saying 4 times 1 over 5. And so that should make these fairly simple. Go ahead and just make sure that you found a common denominator for A, and that you are doing the proper operation for C, and you should be good to go. For multiplication, remember you're just multiplying across the top and the bottom. This question here is sort of a spin on a question that we've already been doing, and for the most part I'm going to give you just a couple hints. I'm not really going to go through the whole thing, because you should be able to just sort of think through it. So use what you know, give it your best shot, and I'll say a couple things in just a few seconds. All right, so we have a 20% solution and a 50% solution, and those are the two things that we are able to work with. And we take 10 liters of this 20% solution. So the one thing that I will say is, like, if you have 10 liters of 20% solution, that means 20% of it is acid, or 2 liters of it is acid. And you want to add some of the 50% solution in order to create a solution that is 27%. So you have this 10 liters, 2% or 20% of it is acid, and you're adding 50% solution. So remember that nothing changes about how you calculate concentration. It's the amount of pure that you have divided by the total. And so I encourage you to think about, okay, what's your initial situation? Well, you have 2 liters of pure and 10 liters of total, and then what are you adding to it? And you think very carefully and how you'd represent it, and go from there. Okay, you can do this, and then to make sure that your answer makes sense, right, go back and think about whether the value you got makes sense in the context of the situation. Okay, best of luck, and I'll see you guys tomorrow.